Artificial intelligence now spans hundreds of tools, models, and buzzwords. By organizing these ideas like a periodic table, we can see how foundational capabilities combine into more advanced systems and real applications. In this video, we will walk through that structure step by step. AI concepts can be grouped into four rising levels of complexity. At the base are primitives, the indivisible building blocks. Above them are compositions, which combine primitives. Next comes deployment, focused on productionizing systems. At the top are emerging concepts, fast-evolving ideas that are still maturing but shape AI's future. Primitive elements represent the simplest AI capabilities, like prompts, embeddings, function calling, and basic agent behavior. Each primitive does one focused job, capturing meaning from text, calling tools, or following instructions. These primitives are analogous to atoms because more sophisticated systems are built by combining them. Compositions arise when multiple primitives work together. For example, vector databases pair with embeddings to enable semantic search, while more structured prompting turns a basic model into a reliable question-answering system. These combinations begin to resemble real applications, although they still rely heavily on careful design and orchestration. Deployment concepts cover what it takes to run AI reliably in production. Frameworks help engineers wire together prompts, tools, and models. Guardrails enforce policies and safety rules. Retrieval augmented generation pipelines ground responses in trusted data. Together, these ideas address reliability, scalability, and governance beyond pure model capability. Emerging elements capture frontier trends: multi-agent systems, synthetic data, red teaming techniques, and multimodal models. These capabilities extend AI beyond single models answering questions. They support richer reasoning, automated testing of safety, generating training data at scale, and combining text, images, and other modalities into unified systems. One group of AI families focuses on action and memory. Reactive elements cover how systems respond to prompts or operate as multi-agent workflows. Retrieval elements handle storing and accessing information across time, from vector databases to embeddings. Together, they determine how an AI system remembers, reacts, and maintains context over many interactions. Other families emphasize coordination, oversight, and modeling. Orchestration elements connect multiple components into cohesive flows. Validation includes testing, red teaming, and guardrails to keep systems safe and aligned. Model families cover core model types from smaller specialized models to large general-purpose ones that everything else often centers around. A retrieval augmented generation chatbot illustrates how elements combine. First, documents are embedded and stored in a vector database. When a user asks a question, relevant chunks are retrieved, merged into a prompt, and passed to a language model. The model then generates grounded answers that cite or rely on those retrieved passages. This workflow follows a precise sequence: embed documents, store vectors, retrieve context, augment the prompt, then generate responses. Guardrails or filters can be added after generation to enforce safety and correctness. Thinking of each step as a separate element makes it easier to swap tools, tune behavior, and debug issues. The agentic loop demonstrates goal-directed behavior. An agent receives a high-level goal, decides which tools or functions to call, observes the results, then iterates until the goal is met. Frameworks, function calling, and models all cooperate, so the system can plan, act, and adjust autonomously rather than answering a single prompt. Viewing AI as a periodic table highlights how simple capabilities combine into robust applications. Primitives become compositions, which are deployed and continuously extended by emerging ideas. By understanding families, rows, and example workflows like RAG and agent loops, you can design AI systems in a more structured, modular way.